So let's have some examples for improper integrals. Let's start with easier problems first. How about from 1 to infinity, 1 over x to the power of 3/2 dx. Okay, so now the upper boundary is infinity, so turning this into a limit problem, limit as some t is approaching infinity, integral from 1 to t, x to the negative 3/2 dx. And limit as t is approaching infinity, I have adding 1 to the negative 3/2, I get x to the power of negative 1/2, dividing by negative 1/2 or multiplying by negative 2, same thing. And that is going to be from 1 to t. And now what I'm going to do, I'm going to actually take the constant negative 2 out. So this equals negative 2 limit as t is approaching infinity. And x to the 1/2 is 1 over square root of x from 1 to t. And so this equals negative 2 limit as t is approaching infinity. Then I have 1 over square root of t minus 1 over square root of 1, that is 1. Okay, so notice that this equals negative 2 times. If I, as t right here, this t is going to infinity, this is going to 0. So I'm left with negative 1. And negative 2 times negative 1 is positive 2. So this is convergent. Convergent. Let's do another one. How about something like this time from negative infinity to negative 1, x to the negative 1/3 dx. So let's turn this into a limit problem. Limit as some t is approaching negative infinity from t to the negative 1, x to the negative 1/3 dx. So now limit as t is approaching negative infinity, adding 1 to the negative 1/3, I have x to the power of 2/3. And instead of dividing by 2/3, I'm going to multiply by 3/2. And that is going to be from t to the negative 1. Okay, so what I'm going to do next step, I'm going to go ahead and take the 3/2 out. So I'm going to write here limit. Let me just go ahead and go to the next page. So limit as t is approaching negative infinity, 3/2. And we said this is x to the power of 2/3 is the same as saying cube root of x squared. And we had this from t to the negative 1. So this equals, let me bring the 3/2 totally out and say limit as t is going to negative infinity. Putting the -1 in, -1 squared is a positive 1, cube root of that is just a 1 minus cube root of t to the second. So what happens in here as t is approaching negative infinity, t squared is approaching positive infinity, and and the square root of cube root of positive infinity is a very, it's positive infinity because as t is getting larger and larger, t squared is getting larger and larger and larger, cube root of that is getting larger and larger and larger. So what I'm left with is 3/2 and 1 minus infinity. And so that equals 3/2 times 1 doesn't make that much difference, just a 3/2, but 3/2 constant times negative infinity is still negative infinity. So this one is divergent. Divergent. Okay, let's do one more. I think we have time for one more. Suppose, let's do something with trig problems. How about from 0 to infinity sine squared of x dx? What I'm going to do here now is turn this into a limit problem as some t is approaching infinity from 0 to t sine squared of x dx. So now I'm going to break down this sine squared of x using reduction formulas. This becomes limit as t is approaching infinity from 0 to t 1/2 1 minus cosine of 2x and is dx. So of course I can take the 1/2 out, and let me go to the next page. So this becomes 1/2 limit as t is approaching infinity. Integral of 1 is x minus integral of cosine of 2x is sine of 2x, then chain rule in reverse. I get a 1/2 in here from 0 to t. So this sequence, change color, 1/2 limit as t is approaching infinity. When I plug in t, I get t minus 1/2 sine of 2t minus, when I plug in 0, x, yep, everything becomes 0 in here. All right, so this equals 1/2. So notice that this t is now becoming, for plugging infinity for that, minus this part really doesn't matter because sine of 2t alternates between +1 and -1. So really that this is this number right here is just between +1 and -1. And actually multiplying it by 1/2, it's even smaller. So this equals infinity. And so this one is divergent. And really, when I say this equals infinity, I shouldn't say that. This is approaching infinity. And so this one is divergent. I'll do more video for you soon. Thanks.